So, hi everyone. Today we are going to be discussing the LeetCode Weekly Contest 272. So, let's first talk about the difficulty level of this contest. I think this contest was uh, easier as compared to normal weekly contest. The first three questions were pretty trivial, I would say, and like uh, for the fourth question, if you get the idea, then its implementation is pretty trivial, but its idea is good, right? So I'll also tell you, like, I got two penalties in this question, and I'll tell you why I got this. Like, I got the idea in the first solution itself, but due to a silly mistake, I got those two penalties. So I'll let you know what mistake I did. So okay, I'll not spend much time on the first two problems. They are really trivial and only implementation based. You just have to do what they have asked you to do in the question, right? So okay, so move on to the first question. So here you have to find the first palindromic string in the array. You have to start scanning the array uh, from the left, and as soon as you reach the first string that is a palindrome, sorry, you have to return that string. Okay, nothing much. And if there exists an array in which there is no palindromic string, okay, then you just have to return an empty string, right? Now I hope that all of you know what a palindrome is, and it seems like most of the people knew. So that's it, like simple. You just have to start the traversal from here, and as soon as you reach a string which is a palindrome, you just need to return that. Okay, so the constraint here was the length of the word was 100, and the length of a string in the word was also less than 100. So brute force will work properly here. So what I did was I just initialized a string variable named answer, and I took the size of the word, although it was not needed. Then I started iterating on the words vector, uh, and then I just reversed my current string, and I checked whether the reversed string is equal to my initial string. If it is, then that is my answer, right? So I just make my answer equal to that current string, and I break. And if in the entire loop I'm not able to find any string which is a palindrome, then initially I have already initialized my answer with the empty string, right? So empty string will be returned. Okay, all right. So let's move on to the second question. This question is also a very trivial question. You just have to do what they have asked you to do. You don't have to apply your mind, nothing. Like what you have to actually do is they will give you a string and a vector of integer. Okay, so for example, in any vector there will be some indices. The value of any element in the vector is going to be in this range, that is, it is going to be lesser than or equal to s dot length minus 1 and greater than equal to 0, right? So suppose the current element in the vector is 5, right? So what you have to do is you just have to insert a space uh, before adding the fifth character of the string. Let's see what I'm talking about. Like, see, suppose my vector here is 5 comma 9, right? And my string is enjoy your coffee. Okay, so I come here and I see that index 5 is written here. So what I'll do is I'll just go to my string. I'll count 0, 1, 2, 3, 4, and 5. I'll reach my fifth character. Now what I have to do is I have to add a space before adding my fifth character, right? So what I'll do is I'll just add a space, and then I'll add my fifth character, and I'll continue doing the same thing. Then I'll reach here. I'll see that okay, I have to add a space at ninth character. So this was the fifth character. So this is sixth, seventh, eighth, and ninth. So C is the ninth character. So before adding C, I have to add a space. So I'll just add a space here, and then I'll just concatenate all the remaining characters, and this is going to be my answer. That's it. You don't have to do much. So it is a very easy implementation question. What I did was I took int n equal to s dot length and m equal to space dot size. I initialized I and 0, I and j with 0. I tells me the current character of the string, and j tells me the current element of the string, right? And I also initialized my answer string to empty. Now I am looping over this over this until my I is lesser than n. That is, I have some character to process in the string, right? So what I do is I check whether my j is lesser than m. That is, whether my j is not greater than the size of my vector. And if it is lesser, so I just check whether the value at that index is lesser than equal to I. If it is lesser than equal to I, that means before adding the character I, before adding the character at index I have to add a space, right? So I add a space here, and I just increment by j here, j plus plus, right? And at the end I just add answer plus s of I, and then I increment I plus plus and return answer. Now why this? Now you may ask that, okay, it can be the case where the spaces is not sorted, right? Because this thing will only work when it is sorted, you know. But they have told me in the constraints that all the values of spaces are strictly increasing, so I don't have to sort it, right? So it would work like properly. Second thing, you may think is that the time complexity of this. First of all, just try to think about the time complexity of this this code. uh, this may seem like it is like n into m or something, but it is not n into m. It is O of n plus m. How I am saying that? Actually, O of max of n plus m. How this will happen is, see, for every index I, right, I'm visiting it only once. In any string, I'm visiting a character only once. I'm not going back to the character. And the same thing goes here. I'm not updating my j variable to 0 again and again whenever I enter in my loop, right? So uh, every element in spaces will also be visited once. So this loop, if I just think about the total number of times that this loop will run, is O of m, and the total number of times this loop, this entire loop, if I ignore this, this entire loop will run is O of n times. Now this is not adding, this is not multiplying the complexity, right? Because if I was visiting every element of the spaces multiple times, then yes, it would have added into the complexity. But here I'm just visiting once, so it is not multiplying the complexity, and hence the uh, uh, you know the complexity of the solution is O of n plus m. But since n and m are comparable, as dot length is 3 into 10 is to the power 5, and same goes for spaces dot length, so I would say like it is asymptotically you can say it is O of n. Okay, all right. So let's move on to the next question. So in this question, you'll be given an integer array prices, which will represent the daily price history of a stock, where prices of I is the stock price on the ith day. Okay. Now, when I first read this statement, I thought it is going to be a DP question. Like you must have solved those famous DP questions of buy and sell stocks, right? So I thought it is going to be a DP question, but it was a pretty simple question. So it says that a smooth descent period of a stock consists of one or more contiguous days, such that the price on each day is lower than the price on the preceding day by exactly one. The first day of the period is exempted from this rule. All right. Now we just have to return the number of smooth descent periods. So in simple language, what you have to do, you just have to return the number of subarrays such that the element at any index I plus 1 is equal to a of I minus 1. That is, it is just one less than the previous element. That is it. You just have to return the number of subarrays. Now the trivial approach is to calculate all of the subarrays once, and then for each subarray you check whether that subarray is satisfying this condition or not. If it is satisfying this condition, then you increment your answer by 1. Otherwise you move on to the next subarray. But you cannot do that. Why you cannot do that is because the length of the prices, the size of the prices array is 10 raised to power 5, and we know that if we want to generate all of the subarrays, the time needed would be n square, that is 10 into 10 10 into 10 raised to power 5 into 10 raised to power 5 equal to 10 raised to power 10. Now we know that in 1 second a computer can only perform 10 raised to power 8 operations. So if I go by that method, then it would probably take 100 seconds, right? And that is obviously not allowed. So we have to be a little clever here, not much actually, but just a little clever. So what you have to do is instead, first of all, look at this, like every single element is always a decent period, right? Always a decent period, you know, because of a stock consists of one or more contiguous days. So every single element is always a smooth decent period, right? Okay. So next thing that you have to see, suppose by some miracle, okay, I'm able to get all the subarrays in which the elements are uniformly decreasing by this process. That means suppose I get this subarray and this subarray, I get them in different buckets, okay. So this subarray is following the operation that a of I plus 1, let's say I is 0, so a of 1 is equal to ai minus 1, correct. Then 1 is also lesser than 2 by 1, you know. So this is satisfying my operation, right? And this cannot be added to this array because 4 is not equal to 1 minus 1 is equal to 0, right? So this will make a different bucket. So suppose I have 3 elements in my bucket, you know. Okay, now what I can do is, I know that every single element is always going to be my answer. So I just increment the size of, let me just show you this, and here, okay. So I know I have two buckets, right? I have separated uh, my array into sub arrays which are continuously decreasing in by one. Okay, so I have two buckets here. Okay, now let's look at this bucket. Okay, now I know that every single element is going to form a valid subarray, right? The subarray, a smooth decent period, right? So if I just look at this array, then I'll get three for sure. I'll get three, uh, you know, uh, three smooth decent periods, right? Now let's look at the length of two. Since this entire array is decreasing continuously, right? Decreasing by one. So if you take any two contiguous elements, they are also valid, they're also a valid smooth decent period, because if three elements form a valid smooth decent period, then obviously two elements are forming that. Because if these two elements were not forming it, right, so there could never have been a case that these three elements would have been forming it, right? So you can take these two elements and these two elements, since we have to take subarrays, right? So it would come out to be two, and then just look for the length 1 and length 3, and there is only one array. So here the answer becomes 6, right? So if you look closely, you just need to for every bucket you just need to tell me the number of subarrays that can be formed by that bucket, right? So the number of subarrays, if n is the number of elements in a bucket, is, let's in terms of bucket you can say array. If n is the number of elements in an array, then the total number of subarrays that can be formed is n to n plus 1 by 2, right? uh, if you don't know how this occurs, then I'll tell you. The number of subarrays of length 1 is n, right? Because n elements. Number of subarrays of length 2, right, it is n minus 1. Okay, the number of subarrays of length 3, it is n minus 2, because you start by taking first three elements and then you move on, right? N minus 2, right? For length 4 it is n minus 3 up to so on. And for length n, because the greatest the longest subarray length in an array of length n can be n, right? So in that case only one subarray can be formed. So if you look at it, it just reduces to a very simple sequence, that is 1 plus 2 plus 3 plus dot 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 plus n minus 1 plus n, whose sum we already know it is n plus n into n plus 1 by 2, right? So that's why. So you just need to find these different buckets that are continuously decreasing, and you just need to add your answer the size of your current bucket, right? So that is what I am doing here. I am initializing my answer by 0. I'm taking the size of the vector, and what I'm doing is I'm starting from left point and I'm going until the last element of the vector, and I'm you know taking taking a different variable to find the right bound. If I'm including this ith, I am always including my ith element, but I have to know the rightmost bound. uh, like for example here I start from I equal to 0. Now I need to know the rightmost bound of this longest descent, smooth descent, right? So for that I am taking the help of another variable j, and I'm initializing it with I plus 1, and I am also initializing my count variable to 1. This count is just going to count the number of elements in my smooth descent period, current smooth descent period. So what I'm doing is I'm iterating till j is lesser than n, and v of j is equal to v of j minus 1 minus 1. That is, it is satisfying the condition. If it is satisfying the condition, I move on to the next element and I increment by count by 1. That means one more element has been added into my current bucket. And after this loop has ended, I have reached to an element that either I have reached j equal to n, or I have reached to an element that is not part of my current bucket, right? So I'll have to start my next iteration from that element. So I just make my I equal to j, and I just add into answer a count into count plus 1 by 2, count into count plus 1 whole divided by 2, because count is the number of elements in my current bucket. And I just do this process, and at the end I just return the answer. So yeah, so what would be the time complexity of this approach? The time complexity of this approach is going to be O of n, since this loop is going to run only O of n times. It may not seem like it is going to run for more than that, but you'll have to look closely, because once I'm visiting an element, I'm not visiting it again, right? I'm never going to visit it again, right? So every element is being visited only once. So how many elements do I have? I have n elements. So what is going to be the time complexity? The time complexity is going to be O of n. And regarding space complexity, I'm not using any extra space here, so it's constant, right? Okay, I hope it's clear. Let's move on to the last question. This question is like this was not very tough, but I just made very silly mistakes. First of all, I want to show you. Sorry. First of all, I want to show you that during the contest, I made two wrong answers, and that there were silly mistakes. I'll show you what. So let's first understand the question. So I'll be given a zero indexed array consisting of n positive integers and a positive integer k. The array ARR is called k increasing if array of I minus k is lesser than equal to array of I, and it holds for every index which is greater than equal to k. Right. So for example, here they have given the example. I have to see if this array is k increasing for k equal to 2. Right. So what I'll do is I'll start from the index 2, and I'll see whether index 2, sorry, array of 2 is greater than equal to array of 2 minus 2. Now array of 2 is 5, and array of 0, 2 minus 2 is 4, so it is greater, right? So it satisfies. So I move on to the next index. Then I check whether this is greater than array of 3 is greater than array of 3 minus 1. that is array of 1, array of 3 is greater than 1. So yeah, it satisfies here. Now I move on to the next element. Here I check if element if 6 is greater than equal to 5. Now array of 4 is greater than equal to 2, right? So this index also satisfies this quality. Now I move on to the last index. Here array of 5 is 2 and array of 3 is also 2. So it satisfies this condition, right? So all right, sorry for the interruption. So yeah, so this array is satisfying this property for k equal to 2. All right. So you know, yeah, so this array is satisfying uh, this property for k equal to 2. So it is 2 increasing, right, in this terminology. And however, this array is not k increasing for k equal to 1. Why? Let's start from array of 1, right? Array of 1 is 1 and array of 1 minus 1, that is array of 0, is 4. So array of 1 is not greater than or equal to array of 0, right? So at the very first index this condition fails, so it is not k increasing for k equal to 1. Now in one operation what we can do is we can choose any index I, and we can change array of I to any positive integer of our choice, right? So like you need to look at this into any positive integers, because see, the number of total submissions here is 7,124, but the users who got accepted was only 1,265. So I thought many people made the same mistakes. Like, first of all, you need to notice this thing that you can change it into any positive integer, you cannot make it a negative integer, right? Now we have to return the minimum number of operations required to make the array k increasing for the given k. All right. So I hope the question is clear, and let's move on to the constraints now. So the constraint is the length of the array is going to be 10 to the power 5, and k is also going to be of the same order. So by seeing this constraint, you should understand one thing. This question can only be solved in O of n or O of n log n. It is like sometimes there exist questions which can be solved in log n also, but it is very rare that they'll give you 10 to the power 5 for a log n question. So this question will be solved in O of n or O of n log n. Okay. Second thing, now you have to make some observations, and these observations that I'm going to tell you, these observations form the basis of this of the solution of this problem. So we'll move on to the solution later. First, let's just talk about the observation. Let's just copy any test case. Let's say, okay, we have done this test case, right? So let's copy this. Okay, all right. So yeah, we have this test case. Yeah. Now for k equal to 3, I'll start from I equal to 3, that is 0, 1, 2, 3, right? I'll start from here, and uh, I will see whether 2 is greater than equal to 4. This is not greater than equal to 4, right? So one thing that I know here is I'll have to change either 4 or either 2. I know that, right? I'll have to change any one of them, you know. So which one should I change? I'm not going to talk about it right now, but just keep in mind I'll have to change one of them. All right. Now we move on to the 6. Okay. Now the index of 6 is 4, and I see that array of 4 is greater than array of 1, right? So this satisfies the condition. I do not have to change anything here, right? Now I move on to 2, and I see that 2 is not greater than equal to 5, right? So here also I will have to change one of these, right? So like suppose there was, so for this case, let's just talk about this case first, then I'll do some modification to this test case. So for this case, here you can see for this pair you can change any number, because this number is not influencing any other pair in the future, right? Like this is not the array of I minus k for any array of I in the future, right? So you can either change this or either change this. It doesn't matter, right? So let's say we change this, we make it to 1. Okay. Now, similarly for this pair, this array of I is not the array of I minus k for any future I, right? So you can either change this to or you can change this y. So let's say I decide to change this to 6. Okay. So here my answer will be 2. Okay. Yeah. This is not what I want to talk to you about. I want to talk to you about a more interesting observation. The observation is that suppose there was one other element here, right? It was, let's say, 4, 2, and okay, 4, 2, and let's say 2. All right. Let's do, or let's say 1. Okay, let's say 1. Right. So we have found the answer for this. So do you think the answer would hold for this array if we had changed this? Uh, if we had changed this to 2, then this answer won't hold because this 2 will be lesser than 1. I'm correct, right? This 2 is greater than equal to 1. So I'll have to change this, or I'll have to change this, right? So just notice one thing here, that if I'm adding one more element, right, then this element is going to be in use in the future. So what value I am changing right now, I have to take in consideration that it can be used later also, right? Okay, it can be used later. So I have to change my current element to some value that is optimal, that will give me the optimal answer, right? So one thing is this, like this is not the case that you can change this to anything, and this will not affect this will have no effect on the future elements, right? Second thing that you need to notice, right, any j, let's say for any I, it would only interact with I minus k, correct? Now any I minus k, it will only interact with I minus k minus 1, which is I minus 2 into k, right? Now any I minus 2 into k is going to interact with only minus k, that is I minus 3k, right? This process continues. Now if you take the modulus of all these values by k, what does the modulus comes out to be? For I, uh, let's say I don't know whether I is greater than equal to k, so let's say I mod k is equal to x, right? Let's say, suppose you know suppose it is x, right? So for I, it is going to be x. I minus k, we know modulus is distributive, right? So it would become I minus k, I mod k minus k mod k. Now k mod k is equal to 0, right? So it would also become x. Here also for I minus 2k, same thing, it will also become x, and the same thing for I minus 3k, and so on. So one thing that I see from here is that all the indexes that have the same modulo, I'll have to group them in buckets. That is, I have to make their separate groups, because one group is never going to interact with the other group, right? No element that has let's say whose index has modulus 2, that is I mod k is equal to 2, that element is never going to interact with any element whose modulus with k is 3 or 4 or 5 or whatever, right? It is only going to interact with an element whose modulus is 2, right? I hope this is clear. Okay, so what we can do is we can make buckets in the starting on the basis of the modulus value, that is I mod k. So if I make buckets here, so this is for k. First of all, modulus value can range from 0 to k minus 1, right? So I'm writing 0, 1 and 2 for k equal to 3. So mod 0 will be, element will be 4, 4, 0, 1, 2, 3, 2, and okay, I'm talking about this test case in 1, right? So for mod 0, my bucket is going to look like this. Now for bucket 1, for mod 1, my bucket will be 1 6, right? So 1 6, and for 2 my bucket is going to be 5 comma 1, right? 5 comma 1. So just have to work on this, right? Just look at this, just look at this array. You know what I have to do, just forget about the entire problem and just look at one modulus array. What I have to do in this array, if you think about it, I just have to make this array non-decreasing, right? I have to make this array non-decreasing. That is what I have to do, right? I don't care like what is happening to the array in my modulus 1, modulus 2. I do not care about anything. I just care that in minimum number of operations, this array, the array at 0th modulus index, it becomes non-decreasing. This is correct, right? I just need that. So now uh, right, also in minimum operations you need to keep this in mind. In minimum operations, okay, so like some of you maybe like maybe have got the idea by now. For those of you who have not got the idea, suppose you have you know an arbitrary array, let's say 1 2 1 5 6. Let's say this is the array. Now I want to change this array into you know uh, an increasing array. Let's say, just forget about non-decreasing. Let's say I want to change it into an increasing array. Okay, so what can I do? Some of you will say that okay, uh, let's say my first element is 1, then this element can only be 2, right? If it is greater than 2, then it is okay, but if it is 2, then it is better. So it is 2. Okay, now I see, I come here and I see that it is equal to 1, so this cannot be equal to 1, so I'll make it equal to 3, right? I'll make it equal to 3, and suppose this was 3 also. No, okay, I'll make it equal to 3, and then I'll go here, it is 5, it is correct. Then I'll go here, it is 6, it is correct, right? But um, okay, so uh, let's say this was the case, right? So here the number of operations to make this array into increasing array would be 1 2 is correct. Here I'll have to change 1 to 3, so one operation, plus here I'll have to change 2 to 4, plus one operation. Here I'll have to change 3 to 4, 3 to 5, sorry, so plus one operation, 5 to 6, plus one operation, 6 to 7, plus one operation, right? So this becomes total equal to 5 operations, but what if uh, I go by other route, right? uh, like here I'm able to see that I have to you know uh, do 5 operations to convert it into an increasing array. But you know like this is not a proper example of what I'm about to say. Is that if you look at this array very closely, then you will be able to see that the longest increasing subsequence of this array, it is 5, right? The length of the longest increasing subsequence is 5. So I will never want to touch my longest increasing subsequence. Why? Because it is the longest increasing subsequence and I want to do the minimum number of operations. So why would I ever want to mess with like the longest length of my array, which is already, already in the way I want it to be, right? So I'll never mess it with the longest increasing subsequence, and then I'll always only change those elements which are not, not a part of my longest increasing subsequence, right? But here I have to make the array to non-decreasing. I do not have to make it into increasing. You have to remember this. This was my first mistake. I have to make it into the non-decreasing array, not increasing array. So what you have to do, you just have to find the length of the maximum non-decreasing subsequence of array in every modulus value, and just add into the answer the total size of the array minus the length of the longest non-decreasing subsequence. That is it. That is pretty much the question. Now people someone would think like how to find the length, how to find the longest non-decreasing subsequence. Now if you're asking me how to find the non-decreasing subsequence, I'm not talking about that, and you also do not have to talk about that, because in reality you don't have to find the subsequence. What you are concerned with is only the length of the subsequence, right? Just think about it. If you have the length of the longest non-decreasing subsequence, you know, that is it. That is what you need. You don't care what are the values in that non-decreasing subsequence. If you have the longest non-decreasing length, then that's it. That's your answer, right? So that's the same that is the only approach that I applied. A prerequisite here would be you should know how to find the longest increasing subsequence in O of n log n. If you don't know, I will put the link to the GFG article. It explains it well, or you can watch any video. It is a very simple thing. It's not like it is very difficult. Okay, so right, so let's just move on to the code. So first of all, I make a vector which from 0 to k vectors of vectors, and I take the size of my array. Now I iterate on my vector, and I push the value of array of I, that is array of I, into v of I mod k, which I explained it here, that I need all the elements that are giving the same mod, whose indexes are giving the same modulus with k, in one bucket. So here these are key buckets, and I'm pushing this element to the valid bucket. Okay, now I declare my answer and initialize it with 0. What I do is pretty simple. I iterate on these k buckets, and I take a vector here, vector int L, and this L is going to be needed. It is needed to find the length of the longest non-decreasing subsequence. Okay, so I just take this current v of I as a independent array, and I just find the longest non-decreasing subsequence of that array. Now the only difference in finding the longest increasing subsequence here, you must know one thing, like when you go to the article of GFG, here it won't be upper bound, it would be lower bound. Why? Because they are finding the longest increasing subsequence, but we are concerned with the longest non-increasing, longest uh, okay, sorry, longest non-decreasing, right? Like it should not decrease, it can be equal, but in longest increasing it should be strictly increasing, like none of the elements can be equal, right? So here you will find there a lower bound, right? And also in the at the end the vector is going to contain a longest increasing subsequence, but here in the end the vector is not going to contain the longest non decreasing subsequence, but the length of the vector is going to tell me the length of the longest non-decreasing subsequence. Why is that? You will have to think about it a little, but if you read the article about finding the longest increasing subsequence, it is like pretty trivial to come up with this approach by reading that. So I just find the longest, I just write the code of the longest increasing subsequence, and I just change lower by upper, because I have to find the longest non in decreasing subsequence. So I also have to allow equal elements, right? That is why I'm using upper bound, because if I was using lower bound and suppose a same element comes, right? Same elements come. Suppose like I have current values 3, 3, right? So initially my vector L is empty, and I go there and I found the lower bound. Let's say it was lower bound, right? So the lower bound is going to be L dot n, because my vector is empty. So I'll just push 3 into the vector, right? And then I'll move on, and I'll again found the lower bound. Now this lower bound is going to point to the 3 that I have inserted in the previous iteration in my vector, right? So what I would do, it is not equal to L dot n, so I would replace it with this current element, that is, it would become 3 again, and the size of my vector L will be 1. So at the end, the length of longest increasing subsequence, strictly increasing subsequence, it would be 1, right? L dot size will be 1. But if this was the case, if this was the vector for this current modulus I, then this is a valid vector, valid array, right? I don't have to change anything in it. I hope you are with me, right? I don't have to change anything in it. So why would I like, if I had calculated LIS, longest increasing subsequence, it would have given me that I have to perform one operation. But if I am calculating longest non-decreasing, so here I will find upper bound, and upper bound for the second 3 will also give me L dot n. So here I also I'll push 3 into it. So here final answer will become, final size of the vector will be 2, and here I'll have to perform 0 operations. So that is why I'm using upper bound to, take care of the duplicate values. Since if I have equal values, then I don't have to do any change into them. So that is it. After doing this loop, I have the length of the longest non-decreasing subsequence in my L. The size of the L is the length of the longest non-decreasing subsequence, and I just subtract that size from my current bucket size. And since those are the elements that I'll have to change, because I have this longest longest non-decreasing subsequence. Okay, let me just write it so that it is clear. Longest non-decreasing subsequence size is equal to the size of vector L. Okay, so I don't have to mess with them, right? Just like we talked about earlier, like if I have to transform my vector, I don't want to, in minimum number of steps, right? I don't want to mess with my longest subsequence, which is already valid. So I'll just have to change the, uh, change the values of the vector, change the values of the vector, change the values of the vector which are not part of this subsequence. So I'm just concerned with the number of such elements. So I'll just do v of I dot size minus L dot size. This will give me the number of elements which are not part of longest non-decreasing subsequence, right? And that's it. I'll do it for every bucket, and at the end I'll just return my answer. So the question arises that what is the time complexity of this approach? The time complexity of this approach is going to be O of n log n. Now why do I say that? Because now every element of my original array is going to be inserted into one bucket. Every element will be inserted, and I'll perform certain operations on every bucket. That means certain operations are going to be performed on every element, right? So what operation I am performing? Suppose in any bucket there are n elements, right? So I'm just finding the length of the longest increasing subsequence, right? And the time complexity of this finding the longest increasing subsequence, let's say, is O of n log n, same as the time complexity of finding longest non-decreasing subsequence. So n log n, right? Now this n log n operation is going to be performed for every bucket, right? So the total number of elements, if I sum the elements in all of the bucket, is n only. I have not inserted anything except the initial array that I got, right? So it is n only, and a log n factor is just getting added, and that is also dependent upon like what is the size of the current bucket. So if I have to give you an upper bound, right? So the upper bound here will be O of n log n. It would like not exactly be n log n, but kind of, you can say, like it would be n log n. Like if someone asks you what is the time complexity of this approach, then it would be n log n. Okay, so that is it, right? So if you guys find this video helpful, then please like this video, subscribe to the channel, and please share this video among your friends who need it, right? So yeah, I have to talk to you about my mistakes. So the mistakes I made was, okay, I've passed 82 out of 92 test cases here. In my first approach, I was just doing lower bound here, and I was trying to calculate the longest non-decreasing subsequence using maps. What I was doing was, I was when I'm inserting an element, I was just using making its frequency to equal to 1. Then when I was, if it was already equal to like j, then I was increasing its frequency by 1. And if I was replacing it, then I was just making its frequency 0, and I was increasing the frequency of my currently added element. But this approach was a blunder, right? This approach was a blunder because I got this approach, but I was not able to figure out how to find the longest non-decreasing subsequence. So I came up with this approach. Now, in the next part, I did what we were discussing earlier, right? Here I was able to pass 79 cases. I did what we were discussing earlier. I started from the right and left and went to the right, and just tried to make the area 1 2 3 4, just like that. And same thing, I did from right to left, and I just took the minimum of both of the cases. So this approach was stupid, I would say, but this approach was actually what worked, and I was able to figure this out. But only mistake was that I did not know how to calculate the length of the longest non-decreasing subsequence. So now I know, and I hope you guys also understood. So please like this video, please subscribe to the channel, and please share this video among your friends. And if there is any problem that you want us to make the editorial of, please comment out in the comment section, and we will definitely make the editorial video for that problem. Alright, so I'll see you in the next contest. I don't know of Codeforce's LeetCode or Code, but I'll see you in the next contest. Okay, till then, keep coding, keep learning. All the very best. Bye bye.